Hey, John Gilroy here. What is service mesh? And what does it mean to managing a modern federal network? Hit the music, Manny. Welcome to the Federal Tech Podcast, the podcast that connects you to federal technology leaders. My name is John Gilroy, and I will be your moderator. I had to open with that service mesh thing because Branden knows it backwards and forwards, upside down, underwater at 40,000 feet. But there are people who listen to this podcast that maybe have heard of Tetrate and maybe have some rough idea of service mesh. And I want to bring Branden back in to expand that because they've had even more success in the past on this whole idea of service mesh architecture. And I think assisting with the transition to zero trust and more importantly, I have this in big block letters, Branden, continuous. Not as easy as it sounds, does it?
It certainly isn't.
Rough definition for you're at a coffee shop with someone and your cousin walks in and you explain, what's this? What service mesh is there, cuz? What is it?
Well, at first I want to know why my cousin made it from West Virginia into a coffee shop. But after we get past that, I guess we'll talk a little bit about service mesh. So service mesh, it really, at the end of the day, it's composed of two different parts. And there's the brain, and then there's the worker bees that are actually going out and doing these things. So, previously I got my start in the federal government way longer than I care to share, but, everything was running in a data center then. And you would have, if you had an application, you would go have a server team build you a new server, a new virtual machine, and it would have a web front end that, users would access the front end of that. And then it would communicate with another server that's running a big Microsoft SQL database farm in the back end. And that would go through a series of switches and VLANs and routers to get to that point. And maybe there's a firewall in between. If it's a really critical application, you've got some load balancers in front of it that's going to point you to the closest application server, depending on where you are. If there's latency involved, it'll point you to the fastest responding one. Well, now that you have those different components, but you want to put them in the cloud. And you're not going to be able to go walk on knock on the door at the data center at AWS and say, "Hey, I've got all these load balancers and switches and routers I want to put into my environment. Is it okay if I install those in your data center?" Well, no, it's not possible. So you have to abstract that layer and you have to take it into the application itself. So the service mesh gives you that same sort of flexibility that you used to have utilizing all those different convoluted parts that I just talked about, but it allows you to do it right at the application level. And it sits inside of your cluster. It sits inside with your applications and your microservices and your containers. And at the end of the day, it gives you the ability to do traffic control, gives you the ability to provide security, to provide encryption, mutual TLS, without changing your application at all. And the Istio, which is, again, the brain, will go tell Envoy, which is what we call a sidecar, which sits right next to your actual service itself and implements those changes on behalf of the application. So it really provides not only just a secure, containerized microservices cloud-based application, but it also provides a much more robust, resilient environment as well.
Yeah, I stroll down memory lane for me. I remember those guys in the data centers, maybe with all the keys, and you had the key to this and key to that, and everyone bugging you day and night.
Hey, I was one of those guys.
I had to wear a beeper on the weekend because beepers are in the news now. You used to have to wear the beepers in the weekend, but you'd have a big app. It would be a SQL. Okay. Yeah. Now you may have 100 small apps. So absolutely. Back in the day when Branden was just a young puppy, hey, I could manage this app. Now, Branden, hey, you got to manage, 400 of them continuously. It's a way different ball game here, isn't it? It's not simple black and white anymore.
It truly is. The definition of microservices, that same little application that I described with maybe have three different parts. It could be hundreds or thousands of microservices that make up that same application.
Right.
Well, now your attack vector is absolutely massive. There's so many different moving parts that not only do you have to maintain from an operational perspective, but also your attack surface just got much, much larger. That's really where mesh comes into play.
And so back in the day, no one really worried about that. But now, increasingly, people using microservices. And I think it's almost like, having a garage and putting something in the garage and put something in the garage and putting in the garage. And then you couldn't find it. It's just, you get to the point where the initial idea is not bad, Hey, I just got a leaf cruncher, put that in the garage. Okay. I just got a lawnmower, put that in. And all of a sudden, you can't find anything because the idea that starts off so simply, it doesn't execute well with 500 lawnmowers, does it?
I feel like you were at my house this weekend, my wife yelling at me, trying to find where the grass spreader is so I could put down new seed for the fall.
Yeah. So that's the problem. So the problem is managing microservices. A lot of options. And I think the last time we spoke, we use a very impressive word to impress all your neighbors with Istio. Maybe talk about Istio and what that means and how that attempts to maybe juggle all these microservices.
Yeah, I mean, it's if you look at it, from a high level, how do I get that same sort of operational impact that I used to have across multiple data centers where I've distributed my application? Well, a lot of folks are going to go look at, I need to throw it into not only AWS, EKS, or for my federal customers inside of GovCloud, but I also want to have resiliency, so I want to put it into the Azure government cloud environment, and then working a lot with the Department of Defense. There's a new Cloud One Next initiative where they're talking about including Oracle GovCloud and Google. So that sounds well and good because you have resiliency, you have your applications dispersed across different cloud vendors. But at the end of the day, you're probably just doubling, tripling, or quadrupling your cost because you've not put any sort of mechanism in place to distribute the load across those different cloud service providers, to distribute them across the different regions or zones. So Istio gives you that flexibility and the ability to do so. Hey, I see traffic coming in here and it's going to a service that resides in East 1 of Amazon. Well, there's latency that's being picked up there. There's some degradation of services across East 1. Well, now I got to go back and I got to make DNS changes. I got to move resources over into East 2 or into Azure or whatever it may be. This is a lot of work, and it takes a lot of proactiveness to first determine that there is degradation occurring, but then the process of actually manually failing that over. Istio, in conjunction with Envoy, is going to give you the visibility into when that degradation is occurring. So now you can take that into a proactive state and say, you know what, I do see degradation starting to queue up. I can automate the failover of services, or I can put it into a dynamic state where I'm saying, if I see degradation occurring, automatically start failing users and services over to this other location, and it's done dynamically. So not only are you increasing your reliability, but you're also reducing the overall number of incidents that occur inside the environment. Now, for the federal environment, that could be whether you are a financial company or agency like IRS, that could cause issues with tax returns. If you're the DoD, which we do a lot of work for, this could directly impact the warfighter. So Istio is it's not really a nice to have anymore. This is something that is really becoming crucial for critical infrastructure to ensure reliability and security.
I don't want to get too in the weeds here, but it seems to me the word you used earlier, load balancer, I think a big application, several servers. Okay, we know what that's all about. And so is Tetrate provide a service that load balances microservices? But it's way more than that. It's like that's the first in the checklist, isn't it?
It is. So we actually have our flagship product, Tetrate Service Bridge, actually becomes almost a manager of managers for Service Mesh for Istio deployments. It gives you the ability to collect all the data and metrics that's happening across your entire enterprise. Again, whether that's in one cloud, that's in multiple cloud, that's running on-prem, that's 10 services, or it's 10,000 services. It's 10,000 requests per minute to 1 million requests per minute. This visibility comes into Tetrate Service Bridge, and then from there gives you the ability to put dynamic changes in place. So yes, I want to automatically fail over applications. I want to dynamically load balance our load across all of our different providers. I want Tetrate to become the brains, and I want to put policies in place that's going to ensure that I do not have outages, that I'm proactive in capturing those things. So yes, you can do these things with standalone Istio. You can do it with Tetrate's Istio distribution. You can do it with open source Istio distribution. But if you have multiple instances and multiple clouds, how do you bring that all together and have a manager of managers that's making decisions or giving you intelligence on your behalf to be able to make decisions across the entire enterprise? And that's really where Tetrate Service Bridge comes into play.
Let me try to put this in my old networking 101 perspective. APIs do some of this work. What do they? I mean, they're application programs. They manage applications or at the interface with the applications. And is this just for large applications, or does API work at one level and does the mesh work at a different level? Are these competing management systems, or just a different way to achieve an end?
I think they go hand in hand. An API is going to give you access to different parts of your application, provide different data from different parts of your application, and that's great. But how do you get into that API? Do you open up an API for every single part of your application that you want to provide access to?
No,
Or do and how do you assign privileges and access to those different parts of the API? Well, if that API is running in one location here, but then you have it as a failover or even a active environment. Well, how do you get to those different actives? Who's making the decision to send the traffic to which API? And that's where the mesh is going to come into play. We have the intelligence built in to say, based on who you are, where you are, what sort of classification of data do you have access to, we are going to point you to the right API. And we're going to do that by only opening up one spot instead of opening up an API or all of your API gateways across the infrastructure.
And I think APIs have to be maintained. I mean, there could be a delay in that. And how do you do that effectively compared to something that's, using the word earlier, continuously being managed? I mean, it's just a different approach. And they work together, don't they? They're not one or the other. They have to be optimized, I think, for obtaining this continuous delivery. And one of the people I know about is the Air Force. I know the folks at AFRL and all those people there. I've done lots of interviews with them, and you can brag, but they picked you. They've taken you to the dance here, big time to the dance. I mean, platform. I mean, they're doing it, and these people are getting a reputation outside of the federal government for innovation and security. And if the Air Force wants something to be continuously improved, they're knocking on your door, huh?
We've been very fortunate to have a very long and productive and fruitful relationship with the United States Air Force. It started about 4 years ago. At that time, we were selected to satisfy one of the requirements as part of this new technology modernization effort and move to cloud adoption. One of the requirements is, well, this is great. We can secure north-south traffic. We know all the traffic that's coming into the environment. We know we can make sure that it's not being accessed by foreign adversaries and things like that. But what happens inside of the actual cloud environment? How do we ensure that is secured as well? So originally we were brought on to solve that problem for them in what we call east-west traffic security. So instead of them having to modify every single application inside of that cluster, instead of them going to their customer and say, hey, you can use our platform, but when you build your application, you have to use a FIPS 140-2 or FIPS 140-3 approved encryption library when you build your application. And oh, by the way, we're going to make sure it's certified. Don't worry about it. You build your application however you want to build it. We're going to allow Tetrate to then secure all communication without a single code change to your environment. So by leveraging this sidecar, all traffic coming in and out of your service, we are going to start the encryption process from beginning to end from an east-west perspective. So we had great success in that. And really, we checked the box and we became the de facto standard in what's called a Big Bang, which is it's a series of images and things that have been pre-approved by the Department of Defense to be utilized for applications for the DoD. We took that success, and then one of the next challenges was, well, this is great, but this whole zero trust motion that everyone's going through, and we have to provide single sign-on capabilities. They have to be able to utilize their CAT card to be able to sign in, and we got to make sure that only people that have a need to know have access to this database. But we don't want all of our customers and all of our application teams to go build this functionality into their application. What can you do? So we worked on a project called All Service that allowed us the ability to intercept any sort of login request to any application without any code change. We'll intercept that request, and then we do the integration with whatever sort of identity access provider you utilize, whether that's Keycloak or it's Okta or whatever it may be. So we provide really zero to no code change authentication for the Air Force and for the DoD aligned with that. And then from there, they're like this ambient thing that we're hearing a lot about, which I'm sure you and I will talk about here in a minute. This seems like a really cool thing, but we don't really know exactly when to use it, how to use it, what the applicability is.
I went to your blog, tetrate.io, and saw this blog, and I saw this versus, giants versus commanders. This was ambient versus sidecar. Right. So I'm sure the people in the know give you three, but most people go ambient versus sidecar. I'm barely getting a hand on service mesh. So what is this blog all about? I'll put a link to the blog in the show notes. So is this a debate in the industry, or what is this differentiator here?
I don't know that it's a debate. There's always been this misnomer that by adding a sidecar, you're introducing additional complexity to your infrastructure. You're introducing additional load. You're degrading performance because you've got this extra, sort of hop in the way. So people have been hesitant to adopt the sidecar method, and I think that a lot of that is put behind us now because there's benchmarks and there's data to show that actually no, you probably end up getting better performance by leveraging a sidecar because we can do different things and we manipulate traffic and move in different directions. But that's kind of where the notion of ambient was born. Instead of putting a sidecar next to, sitting right next to every single workload and service, how do we do that on behalf of the cluster? And that's really what ambient mode provides us. It's not just about performance concerns. It's also a lot of major corporations are providing COTS products that are built on microservices, but they're built in such a way that they don't want to provide support to you if you happen to put something else in line with it. If you put a sidecar inside of this application I built for you, well, I don't support it anymore because I don't know what that is doing to my traffic. So that's another good use case where ambient mode comes into play. Okay, well, you still want to get value out of your service mesh, but you can't put a sidecar in place. Well, put ambient mode on, which essentially allows the agent on the cluster to perform acts very similar to what the sidecar does on behalf of all services running inside of that cluster. I don't know that there's a better or worse option. It depends on the scenario. It depends on the application and use case. But it's just another option to further the adoption of service mesh across the enterprise.
So I guess it's named because it can an ambient can look at the environment and make appropriate changes based on that environment, huh?
Right.
And you specified it right there. Not everyone, but certain specific environment would work.
Absolutely. Yep. Just another option for us to pursue and make available for the masses. And when we do so, we want to be a thought leader on it, and we want to make sure that we are providing a prescriptive recommendation based on what you're doing, what you're trying to achieve, and what the best use case is.
Well, we talked a lot about the DoD here, and I love those folks, but NIST has a bunch of specifications that deal with this service architecture here. So they're recognized it as the next development in I guess providing services like you mentioned, authentication and continuous monitoring.
Absolutely. So we're again very fortunate to we've got such good relationships and partnerships with so much of the federal government, and this is just another one of them. We actually have been involved with the research and development agreement, not only with NIST but also with the intelligence community. That's afforded us the ability to co-author and work directly with NIST on these special publications that then the rest of the federal market and to be honest, most of the commercial market falls in line with it as well. What's good for the DoD, what's good for the federal market is probably good for my commercial company as well. So that work has allowed Zach Butcher, again, who's one of our founding engineers, one of the original creators of Istio at Google. He works directly with NIST, and he has co-authored NIST SP 800-204, 204B, 800-207, and he actually has another one that is out for public review right now, 800-233, which talks exactly about what we just discussed. When is the right place to use ambient? When is a sidecar recommended? So that's another one that the audience should definitely check out while it's on public review. Give your thoughts and input. But the NIST has realized that what we developed in the guidelines that we put out in NIST SP 283 back in 1999 or whatever it is, probably does not reflect what the environment looks like today and what it's going to look like tomorrow. So we're sitting in the driver's seat of being able to help federal agencies and, like I said, commercial customers as well, really secure and harden and provide best policies and frameworks for this new generation of infrastructure.
Well, anyone who writes for NIST can be a brainiac, so let's get out of brainiac mode and get back to what's in the garage mode. Okay. So Branden finds a drill on sale, puts it in the garage. Then he finds a leaf shredder, puts it in the garage. Then he found a bicycle, puts it in the garage. And he's got another bicycle. And then his wife buys a bicycle. And his kid buys a bicycle. And what the heck's in the garage? I would think that back in the day, if you understood that you had a SQL server, but now how do you know how many SQL server, or how many? So does Tetrate help with just this first step here, just identifying what's going on there? What they call transparency, or finding out what you have on your network.
It's actually a great question. So when I go into customers, especially in the federal environment where they have historically been sitting on-prem, been sitting in data centers for so long, and now they are making this move into adopting cloud native services. It's a migration problem. How do we get from point A to point B? But two, how do I know what I have today? When I ask that question, maybe if I go and get the network team and I get the security team, and I get the server team, and I get the end user computing team. Maybe if I get everyone in a room, we have 3 days and a big whiteboard. Maybe we will, get some sort of diagram that looks like, John Madden back in the day drawing stuff on the board. Maybe we get a depiction of what this thing looks like. But with Tetrate Service Bridge, we do exactly that. We will actually go in and we start mapping out. We will discover the services that are out there. Not only the services that are out there, but also the communication paths between them. Because it's, if you look at it, one of the mantras of the DHS Continuous Diagnostics and Monitoring Program that came out about 10 years ago is really around you can't manage and secure what you don't know about. So if you don't know what's out there, you don't know how they're communicating, how do you expect to secure them? So by not only showing you what's in your environment, but showing you the communication paths, we can take this attack surface that I talked about earlier that could be, 100 services to 1,000 services or whatever the number is. Well, I can show you what the communication path is. And when I show you the communication path, now we can start providing recommendations on securing that communication path. So if someone were to compromise a particular, let's say they compromise the Apache front end service that's hosting some sort of website, what else can they get to? Well, for most organizations, because they don't have visibility, they probably could get to anything else in that cluster. But by leveraging TSB, giving that visibility, we can now start recommending policies, whether it's Kubernetes network security policies or Istio policies, that would say, hey, you know what? This Apache web front end, it only needs to talk to this backend service, and that's it. Well, here's a policy that's going to do that. So now if I were to compromise that Apache front end, well, I can only go to one place. That's it.
Yeah.
So it's unfortunately we did get compromised on that one web front end, but we reduced that overall attack surface and basically mitigated where that attacker can move through the environment. So it's discovery is one thing. Hey, I'm telling you what it is, but hey, how do I actually secure what you told me about? And it's been really impactful for a lot of our customers.
So, Branden, we opened up with a silly reference to 25 years ago, and you with a bunch of keys working the weekends. Let's go back 7 years. There's a phrase that was popular 7 years ago. I'm sure you can find in Google Trends was shadow IT. Mm-hmm. This is where little John Gilroy walks in and get up my credit card, and I have some kind of a application I'm paid for or something. Now that's about as obvious as a big elephant in the room. Today, it could be that a developer puts in and doesn't even know it. And there's a service that automatically starts and they didn't even realize this. And it wasn't the shadow IT. It was the developer who started it, or maybe it automatically started and they didn't realize it was happening. And you might need to have a bigger flashlight to find out everything in that garage, because something could have just, all of a sudden the lawnmower is reproduced. Or you and you didn't even know it was in there. Oh, it was inside the box of the lawnmower. Oh, I see. So that can happen too. Just identifying it's harder now.
Absolutely. I mean, anyone can go to AWS and they can spin up a cloud environment, and that happens a lot.
Right.
And anyone can go to Docker Hub. Anyone can go to any sort of open source repository, and they can grab any container off there and they can spin it up in your environment. Hopefully there's controls in place that are preventing users from doing so, but inevitably it's going to happen. Inevitably, there's going to be some sort of open source container that's been downloaded and has been executed inside of your environment that may have a backdoor or some sort of malicious code that's sitting inside of it. I'm not going to be able to do anything about the code that you download, but what I can do is I can highlight where traffic is going. Hey, you know what? We're actually seeing traffic that's spawning out of this service, and it's actually going through an egress, and the egress is going to this IP address. Well, based on forensics, that IP address we know, may be going to a foreign adversary. So I'm going to give you that visibility throughout your entire infrastructure and say, hey, you know what, there is some activity that's taking place inside the environment. It doesn't look right. Here's where it started. Here's the source IP. Here's the destination IP. Here's some recommendations on policies you can put in place to limit that exposure or that leak. So it goes hand in hand with the rest of the security stack. So ensuring that what's being downloaded is secure, but also, hey, inevitably it's going to end up in our environment. How do we secure that once there?
Yeah. Trying to find out what type of events Tetrate would actually participate in. Probably AWS. I mean, the standard cloud service provider group, huh? And are there? I mean, I don't even know what to categorize you. What would Gartner categorize you as? I don't even know. It's a rather new area, isn't it?
Yeah, I mean, it's at the end of the day, we kind of play into a little bit of everything, depending on what you're looking for. Whether it's it's network reliability, it is network security, it's application security, It is, even there's some web application firewall functionality that you could potentially leverage. I mean, we really kind of are Swiss Army knife that can really be a huge part of the overall stack. So we attend a lot of things. We are in the news. We are active participants in the community. If you look at some of the stats from contributions to Istio and Envoy together making up the service mesh, I think we're number 2 in contributions to open source, right behind Google. So we are out there pretty much anywhere and everywhere. I think I myself am going to be in KubeCon, which is probably our flagship event that we participate in every year out in Salt Lake City. So looking forward to meeting any of your audience out there. Come by our booth. I'll be out there myself. So yeah, we're out there.
I wrote down a military word, and the word's comms. The comms. Well, you guys are like, okay, network comms. What do you guys do? Network comms. What do you mean? Well, we, in fact, communicate with different levels at different times, different speeds. It's almost like, communication. Well, that's way to classify you as comms guys. It's just,
there you go. I like that.
But I don't know how to, how else to describe it. You get so technical so fast, and then you lose your audience. But if you can, network is so complex now, it's hard to figure out where it's going, and different information is coming in from people are talking about petabytes now, which is just a number that I can't spell, I can't pronounce. But how can you manage that without having communication within different entities and different microservices? Well, great. This was a fun interview. I hope people learned a lot about what happened 25 years ago and 7 years ago and hopefully today. You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Branden Wood, Director, U.S. Federal Government at Tetrate. And I'll put a link to that blog in the show notes page. Thanks, Branden.
Thanks, John. Appreciate it.